Hello, we will look now at paired data and a rectangular coordinate system. Uh, Paired data, what I refer to as the paired data is another thing we call ordered pair. Okay, so what I'm really talking about is a pair of numbers enclosed parentheses and separated by a comma, such as 5 comma 3. Okay, this is called this is called an ordered pair, okay, of numbers. The first number, as you may know, in the pair represents the x. So whenever we have an ordered pair, okay, 5 comma 3, this value here is the x coordinate, and this value here is the y coordinate. And that's why we sometimes refer to them as the xy. Okay, so because sometimes when we write as 5 comma 3, we say this is x and that's y. Okay, so this will really help us in understanding how to deal with equations with two variables. How do we graph equations? Okay, so the standardized way in which we display pair data, we use what is called a rectangular coordinate system. So we use pair data when we have the rectangular coordinate system. And this is something what we refer to as the XY axis. So you have all seen this before. This is our x-axis, and here we have our y-axis. So we usually write y here and x here, meaning x-axis and y-axis. And then we usually put some numbers to indicate 1, 2, 3, and so on. And then on this side here we have -1, -2, -3, and so forth. And then on this side we have positive. Okay. So this here is what we call the y-axis, and this is the x-axis. Yeah, we don't usually write axis, we just write x and y. you will notice that on the x-axis, as you move this way, okay, you move in the positive direction, and likewise, if you move this way, it's positive also. So this is positive direction. And then if we go this way, it's negative, and this way is also negative. In addition to this, yeah, I can redraw this. And what we generally say is, we refer to this as quadrant 1. Refer to this region here as quadrant 2. Refer to this region here as quadrant 3. And refer to this region here as quadrant 4. And this point where the two lines intersect is what we call the origin. Okay, that point is where x is 0 and y is 0. It's called the origin. So there's a couple of names. We refer to this as the xy axis, the rectangular coordinate plane, the Cartesian plane, but I think most students call it the xy axis. But there's the three most common name is the xy axis, the rectangular coordinate plane, and the Cartesian plane. And it's really a combination of a horizontal line, right? The horizontal line, which is the x-axis, and a vertical line, which is the y-axis. And we use this to graph ordered pair. For example, if we say graph, or plot, I should say, plot or graph, I think more common we hear plot, the point 3, 4. So you have to remember that x is 3, y is 4. So if we look at this on the xy axis, okay, and it's very important you label your axis. We have 1, 2, 3, 4, 1, 2, 3. Oops, I need to go up some more here. Four, okay. -1, -2, -3, -4, 1, 2. Now, notice here that x is 3. So we look at the x-axis and we identify the point 3. Okay? And because y is positive, okay, because y is positive, from this point, we will go 3 units up. So 1, 2, 3, 4 units up. We want to go, y is 4, 4. And this is the location of that point. This is the point 3, 4. Another way you can think of it, you can think of this as the intersection of the line, these two lines. Okay? It's the intersection of these two lines where they meet. So you can think of it that way also. But it's only one point. Yeah. Likewise, we can look at some more examples. We can say plot the point I'm going to give you a bunch of them. A now is 2 comma negative 3. The point B is negative 4 comma 1. The point C is 2 comma 0. Or let's make that negative 2. The point D is 0 comma minus 4. Okay. So the first thing I'm going to do is make my XY axis so I can graph my lines, my points. So here's the y-axis, here's the x-axis. 1, 2, 3, 4, 5. 1, 2, 3. After my parentheses here. 1, 2, 3, 4, 5, 4. So let's put in the numbers so we know what's going on. Okay. So remember, the first number always represents an x, second is a y. So x is 2, okay? X is 2, which is here, and y is negative 3. So now we go down to negative 3, and this will be my point. So this is the point A, which is 2 comma negative 3. Yeah. If we look at the point B, this is x, that's y. So x is negative 4. So I go to negative 4, I go to negative 4, okay? And then the y value is positive 1, so I go up 1 unit. So this here will be the point B, which is negative 4 comma 1. Okay? If I look at the point C, remember this is x, that's y. So C is negative 2, x is negative 2, sorry. X is negative 2, but then y is 0, so we don't go anywhere, so we stay on the x-axis. This is the point C, which is negative 2 comma 0. Okay. If we look at the point D, this is x and that's y. X is 0, and you will have to remember that the origin is 0. Okay. But then we go down 4 units. We go down to minus 4, which is all the way over here, and this will be the point D, which is 0 comma negative 4. Yeah, that's my point. So plotting points is important. Yeah, plotting points is important because we are able to work with something that's called linear equations. We have looked at equations in one variable, but now we'll look at linear equation written in the form y equal mx plus b. Okay. Now, how about if I ask you to plot the point E, which is 4 comma 1/2. Okay. So the idea is the same. This is x and that's y. So you'll go and identify where x is 4, but y is 1/2. So that's somewhere over here, right? It's a guess because 1/2 is between 0 and 1 and a y. So this is the point E, which is 4 comma 1/2. And And sometimes we will have fraction values to plot. Okay, so fraction values will be a good guess, a fair guess as to where those points are, because you may say, oh, it's a little bit down to be in the middle or a little bit up to be in the middle. So we're just, looking at a very good estimate. So if we plot 2 points, okay, if we plot 2 points, minimum 2 points. So if I ask you to plot, let's say I have -3, 3 and +3, 1. So here we have 2 points to plot. And if I plot those 2 points, so 1, 2, 3 and the negative, 2, 3 and the positive, more, and 1, 2, 3, -1, -2. So x's and y, so x is -3 and y is positive, so we go up here. So this is the point here, -3, 3. Then same idea for the next, this is x and it's y, so x is now 3 and y goes up 1, so here is the point 3, 1. Now, if we connect those two dots, okay, you will notice that we have a straight line, okay, and that line is continuous. It just passes through those 2 points. And that is what we call a linear equation, okay? A linear equation, hence a straight line. Okay? So any equation, so generally we say any equation that can be put in the form ax plus by equals c, okay, where a, b, and c are real numbers. And a and b are not both 0. So a and b are not both 0. We'll see that later on why we say they're both not 0. So this here, okay, is what we call the standard form. Okay, so ax plus by equals c is what we call the standard form. But most of you have seen this one, y equal mx plus b, is also linear. It's also linear, so this is also linear, but it's written in what we call slope intercept form. Yeah, slope intercept form. So they both have the same, they both represent linear, okay, but just different way of writing them. And this one here is used more often, but you can move from one to the other, and I'll show you that in an example. So any equation that can be written in the form y equal mx plus b is considered linear. Okay. Now, how to graph a linear equation? how to graph a linear equation. And there are many ways to graphing linear equation. We will look at probably about 3 of them, okay? 3 of them right now. So to start, what we do, if you're asked to graph, okay, example, graph equation y equals 2x plus 3. Okay, graph the equation y equals 2x plus 3. So what we do, right, and this is, we will use here the table. We will graph by creating a table. So what we mean by that table is that we make a table, okay, x and y, and we randomly choose the minimum amount of values you should choose is 2, but I would prefer if you choose more than 2, just to confirm. So let's say that we choose x, this is randomly, okay, to be minus 1, x to be 2, and then x to be minus 2. Okay, random values. These values here, you are making them up. And to find the y value, now what you will do is to find the y value, we will replace x with random value we guessed. Okay? So the first thing, the equation is y equal 2x plus 3. So let x equals -1. Okay, and if I do this, I have y is equal to 2, and then in parentheses, -1 plus 3. Yeah? Simplifying this, we have y is equal to -2, because 2 times -1 is -2, plus 3. Therefore, y is equal to 1. So this point here is 1. And notice now we have an ordered pair, -1, -1, comma 1. Okay, because this is the x, this is our x, and that's our y. And we do the same thing again. Okay, y is equal to 2x plus 3, and we'll say let x equal 2 now. So we have y is equal to 2, and then we replace x with 2 plus 3. So 2 times 2 is 4. So we have y is equal to 4 plus 3. Therefore, y is equal to 7. So this value here is 7, and the ordered pair we have is 2, comma 7. Okay. And then finally, okay, finally, I will do the third point. Y is equal to 2x plus 3. And now I'm going to let x equal -2. So we have y is equal to 2, and then I replace the x with -2 plus 3. Okay? And 2 times -2, therefore y is equal to -4 plus 3. Therefore, y is equal to -1. So this point here is -1, and my ordered pair for this one becomes -2, -1. And to graph our line now, we will plot these 3 points. Okay? We'll plot those 3 points. So if we draw the xy axis, actually, well, why don't we make it a scale smaller so we could draw this in a smaller graph too. Yeah. So here is the y-axis, here's the x. So this is 1, that's 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So -1, -2, -3, -4, -5, -6, -7. -1, -2, -3, -4, -5, -6, -7. Okay. So the first point we want to plot is x is -1. Okay. X is -1, y is 1. So x is -1 and y is 1 would be this point here. Okay. Then the second point is x is 2, y is 7. X is 2, y is 7 will be approximately here. And then the third point is x is -2, right? X is -2, y is -1. So x is -2, y is -1. This is here. Now, if we connect those those 3 points, our graph should be close to correct. Okay, this is the equation of the line y is equal to 2x plus 3. And we have just graphed our equation. Now, the reason I did 3 points rather than 2 is because the third point is such as a guess. For example, if this point was correct and this point was correct, and then the other point, let's say this point falls somewhere here, then there is no way we could connect those 3 dots with a straight line. Okay? And that's the reason I always suggest you should do at least 3 points. When you become better at this, you only need to do 2. Okay? But for now, I would strongly suggest 3 points for linear equations. Okay? So just linear. Now, so as I said, this is just one method of graphing. It's called by using a table. And the table method is guaranteed to work. It is a little bit long, but it's guaranteed to work. Okay? So let's look at another example. Graph example. Sketch the graph of y equals minus 1/3 x plus 2. So now I'm asking you to graph something that involves a fraction. And we will use the same idea we did above, right? We will graph by creating a table. But there is a little trick, okay? So we will graph by creating a table. And the little trick here is that the numbers you guess. Since we are dealing with fractions here, okay? Since we're dealing with fractions, choose multiples of 3. Choose multiples of 3. Meaning you can choose -6, -3, 0, 3, 6, 9, 12, and so forth. So we will choose -3, 3, and let's say 6. We can even try 0, okay? We can even try 0. Now the reason we do that is because when you plug in those values, right? When we say let x equals -3, and we have the equation y equal minus 1/3 x plus 2, you will notice that when you replace x with a multiple of 3, that you would not have a fraction, okay? Because negative, this 3 and this 3 will cancel out, leaving you with a -1 times a negative becomes +1 plus 2. And that is equal to 3. Okay? So this ordered pair is -3, 3. Okay? What happens when let x equals +3 now? Well, same idea. Y is equal to -1/3 x plus 2. So we have y is equal to -1/3. And we will now replace that x value with +3. By doing that, this 3 will cancel with that 3. So we have y is -1 plus 2. Therefore, y is equal to 1. So this value is 1, and my ordered pair is 3, 1. And then we do the same thing for 0, okay? Let x equal 0. And if I let x equal 0, my equation is y equal -1/3 x plus 2, okay? So y is equal to -1/3, and instead of x, I write 0 plus 2. Now 0 times anything was 0, okay? So we end up with y is equal to 0 plus 2, so y is equal to 2. So this value here is 2, and that is 0, 2. Okay? And we can plot these points, okay? We can plot these 3 points here and then connect them with a line passing through those points. So if I draw my graph, the xy axis, we have 1, 2, 3, 4, 1, 2, 3, 4. And that's another thing too, right? When you pick those values, try to pick small values, because your numbers on the xy axis will be very large, okay? These numbers, when you pick them, try to pick small values. You don't want to pick things like 27 and so forth, because then you will get larger y values, okay? So the first one we want to plot is x is -3, y is 3. So x is -3, and then y is positive, so we go up, and that's our point. Okay, so we've plotted this one here. The next one, x is positive 3 and y is 1, so we go to positive 3 and y is 1, so that's my point. And then the last point to plot is x is 0, y is 2. X is 0, right? Remember 0 is here, y is 2. And then if we connect those three dots, oops, if I connect those three dots, we have this line here. Please make sure when you connect your dots, the line should pass through them. You don't stop on the dot. And you always write the equation minus 1/3 x, okay, plus 2. Always write the equation somewhere along the line. All lines must have an equation written next to them. It doesn't matter where you write it. So I could have written it here, I could have written it here. Just make sure you write it near the line. Now let's just make sure we did that for our first example. Yes, we did. Okay. The equation must be written next to the line. So this here is graphing linear equation, okay, by creating a table. Okay. We can also graph linear equations by finding intercepts. So now we want to graph linear equations by finding the intercepts. Yeah. So first, what is an intercept? Well, if we redraw the xy axis, okay, there are two types of intercepts for linear equations or in graphing equation. There is what is called the x-intercept, and the x-intercept is a point on the x-axis. So this point here is called an x-intercept. And notice for x-intercept, that point will be some x value and the y value is 0. Okay. Likewise, for y-intercept, this is called the y-intercept. Notice for a y-intercept, the x value will be 0 and the point will be some y value. Okay. So for example, in this scenario here, okay, if I have these two dots here and a line connecting them, okay, the x-intercept here would be 1, 0, because this is 1, this is 2, and so forth. And my y-intercept would be 0, 2. Okay, so it's very important to note that in a y-intercept, the x-coordinate is 0, and in an x-intercept, the y-coordinate is 0. And that will help us with the whole idea of graphing using intercept, because what we'll do is really sort of make a table also, but we will choose two specific values. Okay? So, graph 2x plus 3y equals 6 by finding the intercepts. Now be careful, I'm saying intercepts. So you know that there is an x-intercept, there's a y-intercept. So this means we will find x-intercept, and we will find y-intercept. Now remember, to find x-intercept, right? For x-intercept, let y equal 0. And to find y-intercept, let x equal 0. And I showed this to you before, right? For x-intercept, the y value is 0. For y-intercept, the x value is 0. Okay? So our equation is 2x plus 3y equals 6. So 2x plus 3, and instead of y, we replace it with 0. So what happens is that this becomes 0, because 3 times 0 is 0. So you're left with 2x is equal to 6. Okay? Therefore, to get x by itself, we will divide both sides by 2. So x is equal to 3. Now you're not finished, because remember, you chose y to be 0. So the point you really have here is 3, 0. I would strongly suggest, as soon as you find this answer here, write your point. Okay? Write your point. Now, if we continue and find the y-intercept now, 2x plus 3y is equal to 6. Now x is equal to 0. So 2, and instead of x, I write 0 plus 3y, and that is equal to 6. And 2 times 0 becomes 0, so we don't need to write that. So we're left with 3y is equal to 6. And if we do this, we can now divide both sides by 3, and hence we have y is equal to 2. And before you do anything, write the point. The point here is, remember, you choose x to be 0. So the point is 0, 2. Here is your point. Now that we have 2 points, and remember these are intercepts, so it's very important to remember that when you plot these 2 points, okay, when you plot these 2 points, they must fall on the x-axis and the y-axis. Otherwise, you are doing something wrong. So let's look at this one here. Remember, this is x, that's y, okay? So x is 3, and y is 0. So that's my point right there. And it does fall on the x-axis. Remember, for the next point, this is x and that's y. So we have okay. Always good to put some numbers on. X is 0, which is here, but y is 2. That's my point. And now notice it falls on the y-axis, and I can now connect my 2 dots. And that's the equation of the line that we were asked to graph. 2x plus 3y equals 6. So 2x plus 3y is equal to 6. So this is how we graph by finding intercepts. Okay. Now, what happens? So if you really think about this, it is the same as if you had created a table, okay? This is just the same as if you had created a table, xy, and you chose x to be 0 and you find the y, and then the next time around you choose y to be 0 and you found the x. That's really what you did, okay? So you can do it that way also, which in my next example, I may just show you that way of doing it, okay? So let's sketch the graph of y equals 3x plus 5 by finding the intercepts. Now, we know we have to find x-intercepts, so x-intercept, and we have to find y-intercept, or vice versa, y-intercept and x-intercept. Now, what we can do here, okay, we can create a table, okay? These are the two things we have to find. We can create a table and x and y, and remember, to find x-intercept, we let y equal 0, and to find y-intercept, we let x equal 0. So we could use the same table, okay? If you want, we can use the table, and that's exactly what we're doing, okay? So if you want, you could write it this way also, or you could go back and write it the way we did up here, okay? It doesn't matter. So it's all up to you. So to find x-intercept, okay, let y equal 0. And to find y-intercept, let x equal 0. So if we do that, remember our equation is y equal 3x plus 5. So if y is 0, we have 0 is equal to 3x plus 5. So we'll minus 5 on both sides, leaving us with minus 5 is equal to 3x. The plus 5 and the minus 5 cancel, okay? Minus 5 is equal to 3x. And then to isolate x, we will divide both sides by 3. So minus 5/3 is now equal to x. This cancels out to be a 1. So my point, remember my point is minus 5/3, comma, remember we said y was 0, right? We choose y to be 0. And that's where I'm getting the 0 from. So you will have a little problem here to figure out what that is, but we'll think about that in a minute, okay? Now, remember, our equation here was y equal 3x plus 5, okay? So we have y equal 3, but instead of x now, I'm going to replace that with 0, okay? Plus 5. This cancels out to be 0, so we say that y is just equal to 5. So my point is 0, comma 5, right? Remember we chose x to be 0. Now, how do we plot these points? Well, we just have to be a little careful, okay? And neat. We just have to be careful and neat. So the first point, remember 5/3, 5/3 is the same as -1 and 2/3, right, as a mixed number. So that point minus 5/3 is somewhere between -1 and -2. So x is 0, okay? X is 0, and y is somewhere between -1, no, y is 0, sorry, y is 0. So the x is somewhere between -1 and -2. And we just put it there, okay? And then if we look at the other point, x is 0 and y is 5. So I need to go up on my graph a little, okay? And that's my point here. So my 2 points that I have, I connect those 2 points, and that's my equation. Y is equal to 3x plus 5. So when you have a fraction to plot, you just have to be a little bit careful, right? Especially if it's a mixed number. And this is sort of like a good guess. It's a little bit past 1.5. Okay. So this is by finding intercepts. Okay. This is by finding the intercepts. And if you look at my line, it didn't quite pass through 5. So let's see if we can get that again. Okay, it's better. Okay. You want to make sure the line passed through the point that you plot. So we've looked at graphing lines by creating a table, which is what we did here. Okay, that's a table. We looked at graphing lines, linear equations by finding the intercepts, which is what we're doing here. And then there is one more that I think is more widely used other than intercepts. We can graph by finding the slope and the y-intercept. Okay. We can graph by finding the slope and the y-intercept. Now, earlier we said that y equal mx plus b is what we call slope intercept form. Okay? And in this form, when an equation is written in y equal mx plus b, y must be by itself. The m here stands for the slope, and 0 comma b is what we call the y-intercept. So the y-intercept, remember, x is always 0, okay? 0 comma b. So that's a b. So for example, if you were given an equation, if you were given y is equal to 3x plus 4, you should be able to tell, you can tell that the slope is 3 and the y-intercept is 0 comma 4. Now I know in the lower grade, most of you will say, well, the y-intercept is 4. Remember, points are pair, right? They come in ordered pair, so 0, 4. Now be very careful, because if I ask you to identify the slope and y-intercept for the following. So if you have 1, y is equal to 2x plus 3, 2, y is minus 1/3 x plus 4, 3, y is equal to 1/2 x plus 2/3, and 4, y is equal to, sorry, 2y is equal to 4x plus 8. Now, you will notice in this equation, okay, y is by itself. So the number next to the x is the slope. So we can say here that m is equal to 2. We can say the y-intercept is 0, 3. Okay? This here is my y-intercept. That's this value here. In the second equation, y is by itself. Okay? Y is by itself. So I don't have to do anything. So m is equal to negative 1/3. Yes, the slope can be a fraction. And the y-intercept is 0, 4. In the third example, yes, y is by itself. So m is equal to 1/2. Okay? And the y-intercept is 0, 2/3. But in the fourth example, notice y is not by itself. So we must solve for y. Okay? So we have 2y is equal to 4x plus 8. So in this example, you cannot say the slope is 4. Okay? What you must do, you have to leave y by itself. So you'll divide each term by 2. And if we do this, we have y is equal to, because the 2 becomes 2 divided by 2 is 1, 2x plus 4. So now we have m is equal to 2, and we have the y-intercept is 0, 4. Okay? So you have to be careful. Before you can read the y-intercept and the slope, it must be in the form y equals. Okay? Must be in the form y equals. Now, if you can identify the slope and the y-intercept, we can sketch the graph. So suppose I ask you to graph y equals 2x plus 1 by using the slope and y-intercept. So I'm really forcing you now to use the slope and the y-intercept. Okay? So we have y is equal to 2x plus 1. So we know here that m is equal to 2, and the y-intercept is 0, 1. Now, 2 can be written as 2 over 1, right? That's the same as 2. And the reason is because m, which is called the slope is the same as rise over run. Formula you will see later. Okay? The bottom number is the run, the top number is the rise. And we can use this to graph equation of lines. Okay? Now remember, you only need minimum 2 points to get a straight line. Okay? And that's what I'm going to do. Okay? Here is my x-axis, here is my y-axis. So we do have a point. We have a point 0, 1. So x is 0, y is 1. And that's this point here. Okay? Now from that point, I'm going to use that point and use the slope to create other points. Okay? So because the slope is 2, pay attention here, because the slope is 2 and the rise is 2, what I'm going to do, and here we have the run is 1, okay? So I'm going to try to use the same colors. From this point, I'm going to go 2 units up because we had the rise is 2, okay? And since the run is 1, then I'll move 1 unit to the right because it's positive 1. And that is where my second point will be. Okay? So the rise means move 2 units up because it's positive 2. Okay? Because it's positive 2. And the run is move 1 unit to the right because it's positive. I can now connect those 2 dots with a straight line. And this is the equation y equals to 2x plus 1. So this is a much faster technique, right? We don't have to make a table, we don't have to plug in values, we just have to identify the slope and the y-intercept. Yeah? A much faster technique. So let's look at another example. Sketch the graph of minus 2x plus y is equal to negative 3 by finding the slope and the y-intercept. Now, if you look at your equation given, we have minus 2x plus y is equal to negative 3. So you cannot quite tell the slope because y is not by itself. So what we're going to do is add 2x to both sides so we can isolate the y. And if we do this, we have y is equal to 2x minus 3. Yeah. Now you're able to tell the slope m is equal to 2, and the y-intercept is 0 comma minus 3. Okay. Now that we have this, remember m is rise over run, so it's 2 over 1. And now that I have this, I'm able to graph my line. Okay. I'm able to sketch the graph of the line. So we have negative 1, negative 2, negative 3. Okay. The first point I'm going to plot is the y-intercept. We always plot first, because that's the point. Plot first. Okay. So if I plot that point, 0, negative 3 will be here. Now what I do to get my second point is to use the slope. So it's positive 2 over positive 1. So I will go up 2. I will move up 2 because this is the rise and this is the run. I will go up to 1, 2, okay, and then jump 1 to the right. And that will be my second point. And I can keep doing this again if I want. I can play the pattern again. I can go up 2, okay, and jump 1. And that could be a third point if I want. So you could keep playing this over, go up 2, 1 to the right, up 2, 1 to the right. If I connect those dots now, this is the equation of the line y, or we weren't given y, and it doesn't matter which one you want. You could write minus 2x plus y equals minus 3, minus 2x plus y equals minus 3. Or you can write y is equal to 2x minus 3. Either one of these is acceptable. The point is that you write one of them there. Okay? So this is graphing equations that's written in the form y equal mx plus b. Now, there are two special equations that I just refer to them as special, because they are the horizontal line and vertical line. Okay? For a horizontal line, remember horizontal means left to right. Okay? And vertical means up and down. So when you draw on the xy axis a horizontal line, any horizontal line, realistically that horizontal line will be crossing the y-axis, right? If I draw the horizontal line here, okay, horizontal, okay, and because it crosses the y-axis, the equation of that line will be y equal wherever it crossed there. So if this is 1 and this is 2, then the equation will be y equals 2. Okay, so horizontal line will always be in the form y equals some constant. Always be in the form y equals some constant c. C is the value where it crosses the y-axis. Okay, C is the point on the y-axis where the line crosses. Okay, so that's for a horizontal line. Now for a vertical line, if you look at the xy axis again, okay, if you look at the xy axis, you will notice that a vertical line will cross the x-axis. Okay, it crosses here. Let's say that point is C. So the same thing we can say, a vertical line will always be in the form now. A vertical line will always be written in the form x equals c, where c is the value on the x-axis, okay, where the line crosses. Okay, so let's look at an example because we learn better by example. If I ask you to graph the line y equals 5, okay. Now, if I ask you to graph the line y equals 5, there is no x or y to plug in as we were doing before, nor is it written in the form y equal mx plus b. You could put it in the form y equal mx plus b if you want to. Okay? You can put it in the form y equal mx plus b because the m is really 0. But you should understand that because it's in the form y equals, it is a horizontal line. Okay? So y equals 5 will be a horizontal line passing through 5. This is the line. Y equals 5. Okay. So basically, when you see y equals 5, it's telling you to look for 5 on the y-axis and draw a horizontal line there. Okay. Another example is if I ask to graph x equals 3. Well, if you're asked to graph x equals 3, it means find on the x-axis, okay, where x is 3. So we have 1, 2, 3. This is the point. And draw a vertical line now through that point. And this will be the equation x equals 3. So these are two sort of odd ones, right? Two sort of odd ones. Yeah. Another one that may look odd, but it's not, is if I ask you to graph y equals 3x. Okay? So you're probably asking, well, where is the y-intercept? Well, keep in mind, this can be written as y equals 3x plus 0. So it means that b is equal to 0. Okay? And if b is equal to 0, it means m is equal to 3, and the y-intercept is 0, 0. So if we know this, okay, we can graph our line using the slope-intercept method that I just showed you, because we have this point here, and that point is this point here. And I will use m, right? M is equal to 3 over 1. So this is the rise, and this is the run. So from this point, I will go 3 units up, 1, 2, 3, and 1 unit to the right. And that's where I stop, and I put my second dot. Okay. I can now connect my 2 dots. And that's the equation y equals 3x. So it all depends on the way these equations are written, you're able to graph them, okay? So we looked at the pair data, and as you can see, you can't really do any of these graphing if you don't know what a pair data is, and the rectangular coordinate system, okay, and how to graph linear equations.